Raytheon Aircraft, the premier supplier of aircraft to business aviation, is located in Wichita, Kansas. With facilities over 7 million square feet and over 15,000 employees worldwide, they were recently awarded an important contract by the United States Air Force to provide 103 MQM-107D targets to be used by the 475th Weapons Evaluation Group at Tyndall Air Force Base in Florida. Located about 5 miles east of the Wichita headquarters in nearby Andover, Kansas, is the home of Raytheon Aircraft's target group. The integrated product team for the MQM-107 is all under one roof, consisting of program management, engineering, contract administration, marketing, procurement, quality assurance, and production. This integrated product team is dedicated to the production of subscale subsonic targets for all 3 United States services and many international governments. The production line is tooled to economically produce from as few as 6 to over 20 targets per month. Tooling and handling fixtures assure parts are made the right way the first time, every time. Each part is designed for smooth fit and function, both for original manufacture as well as for spare parts. Over 1,500 MQM-107 targets have been produced using the same tools. Most of the detail parts are built in-house. Wiring harnesses, for instance, are made alongside airframe components, assuring installation at the right time during the manufacturing sequence. All key avionics and electrical components are environmentally tested as a major subassembly. The equipment shelf with such items as the autopilot, rate gyros, engine interface box, payload power distribution unit, airspeed and altitude transducers are assembled and tested for continued high reliability performance. Finished bonded honeycomb outer skin parts are assembled into an outer wing panel in this holding fixture, assuring interchangeability in the field, so important for between-mission airframe refurbishment. High temperature and high pressure forming is used to provide important parts for the MQM-107. The aft tail cone, which separates from the target when the drogue chute is deployed and reused after each mission, is hand-laid up using fiberglass cloth and resin, which is vacuum compacted and oven cured for sturdy long life. Aerodynamic fairings for the empennage are built from precise tooling using plastic sheets that are heated prior to forming. The forming process is comprised of 2 steps. The forming tool is raised into the heated sheet, followed by a vacuum that conforms the plastic to the tool. Hand trimming after this process produces a perfect aerodynamic fairing every time. The engine nacelle liner is laid up with fiberglass and resin, cured and trimmed from its mold. Fitting and bonding to the outer nacelle shell produces an annular volume that can be filled with foam to provide additional flotation for water recovery. The nose cone plays a vital role in minimizing damage during ground impact. During parachute descent, the nose strikes the ground first. The foam-filled nose cone crushes to absorb energy. After recovery, the nose cone is easy to replace. Every engine installation is checked out on an engine run stand using the same start box used during target launch. Thrust is brought to 95%, and the environmentally safe smoke oil system is cycled for correct operation. The 1996 Air Force emergency buy, contracted through the Army Missile Command in Huntsville, was critical to the William Tell worldwide competition to be held in November 1996. This is the first time Raytheon Aircraft had been given the responsibility to procure and install all of the mission-essential equipment required for flight. The Raytheon Aircraft production team went to work from the start with a sense of urgency and this goal in mind. In the 3rd week of June, the targets were disassembled and placed in their shipping and storage containers for an on-time delivery to the Air Force at Tyndall Air Force Base in Florida. A special truck was engaged for door-to-door delivery to show our commitment and sensitivity to customer schedule needs. The first 2 production targets were to be delivered June 30th, 1996, 12 months after contract award. Lockheed Martin personnel at Tyndall Air Force Base receive, assemble, check out, launch, and recover both full-scale and subscale targets for the 475th Weapons Evaluation Group. This experienced team was pleased with the target configuration, with only the APC-4 pods and scoring system to be installed in the target before flight. A fuselage retrieval beam is attached and is used throughout the buildup and remains on the target through flight operations and used in the field for target handling during recovery. Several shop stand handling units are available for multiple target build-up capability. Once all the target subassemblies are removed, the container is set aside for later return shipment to Raytheon aircraft to be used again for the next delivery. Among the first to be removed are the engine cowling panels, exposing the engine for checkout and installation. Next, the payloads are examined, such as the power distribution box, the power control unit on the left, the autopilot below, and the engine interface box and rate gyro to the right. On the other side of the vertical shelf is the signal processor vehicle interface unit, manufactured by Microsystems. Above are the altitude transducer and antenna switch. Further aft is the Gulf Range Drone Control System, or GRDCS, with space to the left for the Cartwright scoring system, which is installed by Lockheed Martin personnel. On the opposite side are the L-band transponders, vertical gyro, and battery. To the right of the GRDCS package are switches for fuel, battery, and pilot heat, as well as a connection for the pneumatic seals to prevent water entry into the payload area during water recovery. Outer wing panels can easily be removed and replaced. Special handy fixtures make the engine installation quick and easy due to the 3-point structural attachment, 2 forward and 1 aft. Next, the entire target electrical subsystem is checked out, including the cartridge circuits used to initiate the drogue chute ejection for recovery. Each gyro is removed and tested on a gyro table for proper function. All control surfaces are energized and checked for correct operation and travel. Fueling is straightforward using JP8. Capacity is 61 gallons with a separate 7-gallon smoke oil tank that can also be used for fuel to increase mission endurance. Engine run-up and checkout is accomplished again to assure proper installation. Finishing touches are made on the forward nose, and the target is ready to be transferred to a roadable trailer for transport to the launch site. Recovery system installation is simple. The aerodynamic cone is attached to the aft plate, which is ejected with the drogue chute and recovered with the main canopy. The GRDCS system is used to launch, fly, and recover the MQM-107. It also controls the BQM-34 Firebee subscale and QF-106 and QF-4 full-scale targets. There are 8 control stations that are operational. 2 are used for software development. Up to 4 stations can be used for flying 4 targets simultaneously, and 2 stations in reserve for growth. A complete set of flight characteristics and target system status are displayed and used by the Mission Remote Control Operator, or RCO. These include engine RPM, fuel quantity, altitude, elevator position, Gs, Mach number, indicated airspeed, and vertical velocity. As a flight is controlled and monitored, position on the range is displayed. Turns are indicated and the recovery area and recovery point designated at the edge of the circle. Accurate meteorological information allow the controller to recover the target and predict its impact point with remarkable precision. The GRDCS has been in operation for over 2 years and will be operational for many years to come. The target is held in place on the launcher with 2 shear pins of sufficient size to handle the engine thrust prior to launch. With booster ignition, the pins will shear and zero-length launch is accomplished with 98% certainty. With pre-launch checks complete, engine run-up is started in the control room. The umbilical falls away and the mission started. After 40 minutes of flight, the target recovers. Launch of the MQM-107 is accomplished with the engine at a 95% thrust setting and ignition of the SR-121 solid rocket motor. This booster with 6,000 pounds of thrust brings the target from rest to 220 knots in about 2.5 seconds. The booster then drops away and the target is now flying a pre-programmed climb until the remote control operator takes over and begins the mission. These missions are being flown with the Hayes APC-4 IR pods that are ignited in flight using propane and provide the proper signature for missile firing. The Hayes APC-4 plume pod uses JP8 fuel from the target fuel system, which permits a much smaller pod design. These pods can be hit by the missile without damage to the target. The mission continues when the other pod is ignited, providing a second presentation to the shooter. This target has damage to one pod. The second pod is available for ignition and presentation to another firing mission. Formation flying is routine with multiple targets. Smoke generated in the engine exhaust gas can be commanded to enhance visibility. Recovery can be initiated in several ways. It can be pre-programmed, automatically recovered when below a given altitude, commanded by the remote control operator, or if loss of command and control, the target will navigate to a predetermined spot and initiate recovery. Descent rate is 17 feet per second with a single unreefed 50-foot diameter canopy. Once the drogue is deployed, a timing device prevents the main canopy from extraction until the target has slowed to the proper speed. Although not preferred, water recovery does happen. The MQM-107 is designed to remain afloat for a minimum of 24 hours. The Gulf range is equipped with a recovery ship that deploys and brings the target back for decontamination and refurbishment for its next mission. Both AIM-7 and AIM-9 missiles, as well as AMRAAM, are routinely fired at the MQM-107 for weapon system evaluation. The first two production targets were delivered in late June and completed qualification flight tests at Tyndall Air Force Base 2 weeks later. The Lockheed Martin team, assisted by Raytheon aircraft, finished the qualification flight test in less than a week. Both targets passed their first qualification flights with flying colors and on schedule. Production authorization was received from the Air Force through the Army contracting officer, and sufficient MQM-107s have been delivered to Tyndall to support the 1996 William Tell competition. Continuous MQM production is assured through 1997 and beyond. A dedicated, responsive team is hard at work, producing low-cost, reliable, and quality targets delivered on time. Development of the next generation Super MQM is now underway at Raytheon Aircraft.